Section 2.5, we're going to talk about critical numbers, including relative maximum and minimum points. So let's talk about the relationship between the function f and its derivative f prime. If a function is increasing on an interval a to b, then f prime of x is greater than 0 on that interval. If function f is decreasing on an interval from a to b, then f prime of x is less than 0 on that interval. And remember, that prime symbol is a straight line. So in other words, if I have a function f that looks something like this, since the derivative f prime is the slope at a particular point, then every place that the function is increasing, in this case from, let's say, negative infinity to negative 1, since that function is increasing through this entire section, I know that at this part of my graph, I'm going to have f prime be a positive number, greater than 0. From 1 to, let's say, this is 3, this function is decreasing. Since it's decreasing, my derivative will be negative over that interval. And then from 3 to infinity, it is increasing again. Whoops, excuse me. It's increasing here. So again, the derivative at that point will be positive. So any place a function is increasing, we get positive slopes. So f prime will be greater than 0 here. Any place that my function is decreasing, I will get negative slopes. So f prime of x will be less than 0. And again, where the function is increasing, f prime of x will be greater than 0. So this creates what are called critical points. If c f of c is at a local maximum or minimum on the graph of f, then f prime of c is 0. So let's draw another picture again. So let's say that my graph looks like this. So a local maximum or a local minimum. Now this may not be the highest or lowest point on the graph overall, but for this area and for this area, this is a maximum value and this is a minimum value. If the point c f of c, this point here, is a local maximum or minimum, then f prime at that point will be 0. So you can see that if I drew the tangent line here, whoops, that this tangent line would have a slope of 0. So at any place where we reach a max or a minimum, we'll have a slope of 0 for my tangent line, which means that f prime is 0. If we have a function that has, for example, a vertical asymptote, then at this point there is no f prime. So if at x equals 3, let's say that is, we have a vertical asymptote, then f prime of 3 does not exist. And that's the abbreviation we're going to use, DNE, does not exist. Okay? So looking at the graph, I can now tell several things. I can tell where the derivative is going to be positive, where the derivative will be negative, where the derivative will be 0, and sometimes where the derivative does not exist. So let's see what we can do with that. So in this graph, f of x is the red, and f prime of x is the green. So let's look at the red graph and see what we can tell from this graph. So from here all the way up to -2, my function is increasing. At 2, which is a relative maximum, f prime of x is 0. Well, I should say that since it's increasing, f prime of x is greater than 0. Then the function decreases. Since the function is decreasing, that means f prime of x will be less than 0. Down here, again, we have a critical point, a minimum, so at this point f prime of x equals 0. And from here up, the function is increasing, so therefore f prime of x will be greater than 0. So let's look at our derivative and see if that matches. So from -infinity to 2, we said that the function was increasing, so f prime had to be greater than 0. And it is. These are all positive values. Now listen to me carefully. When we look at f of x, we are worried about increasing and decreasing. For f prime of x, we want to know whether it's positive or negative. So f of x, maybe I should have done it this way, that would have been better. When f of x is increasing, f prime is positive. That doesn't mean that f prime has to be going up. It just has to be above the x-axis. So again, the next section, when f of x from -2 to 0 is decreasing, that means that f prime of x has to be less than 0, which it is. It's below the x-axis. All of these values are less than 0. And then again, from 0 to infinity, my function is increasing and my derivative is positive. Now, how do I know what kind of positive and negative numbers I'm going to have in between? So I'm going to get another color to draw some tangent lines. So down here, if I drew a tangent line, that's a pretty steep slope. And if I go above that up to here, I've got a big positive number. As I come into here, my slope is still positive, but it's a little bit smaller. It's not quite as steep, so it's a smaller number. So at this point, my f prime comes down a bit. When I get very close to my zeros, I have a slope of maybe 1 at this point. And if I get closer to that 0, my slope might be a fraction, something way down here. So as I get close to these zeros, my positive slopes start to level out and become smaller positives. Now, just to the right of my 0, just to the right of -2, that slope is negative, but it's a very small negative. As I go down, come on, as I draw my slopes further down this decrease on my function, these become larger negatives. And somewhere here in the middle, I have the steepest slope, because then they start to taper off again and become closer to the 0. Again, just to the right of the 0, these are small positives, and then they go up and up and up, steeper and steeper as I go up. We're going to do a whole lot of work with this, taking a function graph and changing it to a derivative graph. Again, I'm going to erase this. You can always back up to get it again, or pause if you need to. So again, on my function f of x, I'm going to be looking for maxes and mins, which translate to zeros on my derivative graph. Increasing function means a positive value on my derivative. Increasing on the function, positive on my derivative. Decreasing on the function means negative or below the x-axis on my derivative. I don't know why it keeps jumping. And increasing again on my function means positive for my derivative. So that's it for this video. Get ready to draw some graphs in class.